Hi, welcome everyone. Really happy to have you all here today. We're having our, third workshop, second workshop reflecting on topics. I'm Giulia Guizzardi. I'm the moderator host for today, and I'm part of the community team at the DFINITY Foundation. The topic of today is front-end on the internet computer, and here with me is Kyle Peacock, who's a senior software engineer on the SDK team at the DFINITY Foundation, obviously. We are going to kick things off with the workshop, but I'm going to tell you, I will monitor the chat and I will monitor the Q&A tab. I really recommend that you ask your questions and do your comments on the Q&A option, so it will be easier for us to track all your questions and your comments. And we will save the time at the end to respond to your question. So yeah, if I don't respond right away, you know why. The workshop is being recorded and it's going to go on the DFINITY YouTube channel in the following days. Yeah, they're working at the moment to put up the first, and then we're gonna see also this one on there. So yeah, without further ado, Kyle, if you want to kick things off, I leave the stage to you.
Great, thank you, Julia. All right. So for this workshop, we're going to be talking about front-end development on the internet computer. From what I understand, you've already had like the bit of the onboarding, so you've seen the quick start. So I'm not going to cover things like setting up a wallet, but I do refer you to the smartcontracts.org docs as the place to get started. And really just like pay attention, follow the quick start guide. It's the best path to get onboarded right now. But focusing in on front-end development, for this talk, I'm going to talk about how it works, how to lay out a website that's going to talk to an internet computer backend. And then in the second half, I'm going to talk about using internet identity in your application and interacting with that using the auth client. Please ask questions pretty much at any point throughout the talk. I'm happy to take a step back and explain anything further. And we can also go into different examples, but if there is time, what I'll do at the end is I'll pull up the auth client demo code base and show how to integrate with internet identity. All right. And just worth noting, internet identity is one solution. There are a bunch of other cool options out there. So check out Plug Wallet, Stoic Wallet, and the Identity Labs team, who have a sort of alternative there. They'll have different integration options, so I'll be sticking to what we have from the DFINITY Foundation. But yeah, the ecosystem's evolving, and that's good. All right, so talking at a high level to start, how does the internet computer serve websites? There's a few pieces that need to come together to make this happen. Obviously, it's not a property that most blockchains have. Let's just break this down. The internet computer itself is a network of state machines. These are our canisters. You get some input and they have some deterministic output. They go through their whole consensus thing. That's going to be the pattern that state is managed. And once you have state, you can then write things to storage. And as soon as you can write things to storage, you can start having files, you can start having large assets and all of the other features that you essentially need to run a basic static HTTP server. And those are governed through the network nervous system. So you've got the canisters, then the canisters need to talk to something because they don't directly handle HTTP requests when they're communicating with each other. So what we have are the boundary nodes, which are going to maintain the ic0.app endpoint. And we also have agents, which are the third piece of the puzzle. Those are what are going to talk to the boundary nodes in order to get data from the canisters. So the basic picture is when you have a canister, you have basically two ways to communicate with it. You can call directly exposed methods on it using an agent through the boundary nodes. We also have a special way of if a canister implements the HTTP request method, then you can serve HTTP requests, which is how we're going to serve things like index.html, index.js, your CSS, your images, that sort of thing. So we've got those two paths. You've got HTTP request, and then just talking to it with an agent. So on the boundary nodes, these are responsible for providing the public API and allowing HTTP requests to fetch static assets. If you've interacted with Internet Computer stuff before, you've probably seen this installing the Internet Computer service worker. This is something that is delivered directly from the boundary nodes. It installs a service worker before interacting with the main content. And the service worker is using the JavaScript agent to make calls and validate all of the subsequent assets that you're fetching. So basically on the ic0.app, as distinguished from the raw.ic0.app subdomain, everything is going to be passed with a certificate that is generated ahead of time. And it's going to validate that to ensure that you can have a complete trustless system where any asset can be delivered and you're certain that the certificate matches with the payload. There's a lot to go over there. I think that some other talks will expand on that. But agents are designed to interact with the interface spec, which is linked to on smartcontracts.org. So that's the public interface for the internet computer. And they do a few things. The main agents that DFINITY actively maintains are the Rust agent and the JavaScript agent. And there are several other community organized agents as well for things like Python or Java, Go, and a few others that are out there. So what it's going to do is it's going to manage CBOR encoding and decoding. CBOR is the main format for encoding messages that need to go into and out of WebAssembly, which is the system that all of our canisters run in. They also interpret candid interfaces into an appropriate interface. So as we encode the data, we're going to have an interface for your canister that's already defined by the canister. And this will tell the agent how to structure calls, and it'll know what information it needs to pass and what information it can expect back. So we have like a fully typed stack all the way across. And it also knows how to make query versus update calls to the Internet Computer API. Query and update calls are important. A query call is the fast call. You can basically get a response back straight away. It'll talk to, I think, the nearest canister, subject to change, of course, as the replica evolves. But a query call is just trying to get you your data back as fast as it can. Whereas an update call will go through a full round of consensus so that all of the canisters need to produce their output and then go through the chain key certificate to verify the response that comes back. Update calls are required if you want to have side effects like storing additional data. With a query call, any data that you sort of try and change in your call, like if you try and update a counter with a query, that'll just get discarded and it won't affect the overall state. So update calls take a little bit more time, 2 to 4 seconds, whereas query calls can be more in the range of like 200 milliseconds usually. This is maybe a little more in depth, but I like to drop it into slides just so people can take a look at it. But this is kind of the structure and flow of how an API request from an agent is going to interact with DNS, all of the logic internal to the boundary node for how you structure the canister ID, additional data that's going to go in there. It finds it on the subnet, and then actually talks to the internet computer replica. So all of this is going on in order to be able to send messages into the internet computer and get responses back. All right, so that's kind of like the overall how frontends work. We will get to sort of like what this looks like in a code base in just a bit. But is there anything that's come up so far that we can talk about?
Someone in the chat asked if you can maybe explain can you define what is an agent again? Probably.
Yeah. So we've got a few models in sort of internet computer. So a canister uses what's called an actor, the actor model. So it's one entity that has methods on it. So you're talking to an actor. That's what's going to be your state machine. And when you call your actor, the agent is any piece of code that is structured to basically interact with the Internet Computer API broadly. So like it has some responsibilities in how it structures those calls. And it's basically defined by what is in the spec. But yeah, it's basically just at a high level, any library in a given language that's designed to talk to the internet computer.
Thanks.
Saikat also asks CBOR, if CBOR is what WASM supports, are the browsers going to support it by default? Yeah, I obviously can't make any promises on behalf of what browsers are going to do, but as WASM gets more popular, I think that that's likely going to be something that gets added into dev tools. So eventually, there's also someone, Jürgen has created, a community member has created, I think it's called like the DFINITY something. There's a Chrome extension that you can download from the Chrome store that'll help you decode messages in your dev tools. And it's not the most feature complete thing, but it's pretty useful in the meantime. And you can talk to canisters with JSON. Like we are able to have side effects now with HTTP request updates. There's some discussion of that in the forum. But that is still something that is kind of like evolving. Yeah, well, we'll see where that goes. You can certainly craft JSON responses and serve it over HTTP. And theoretically, you can parse them as well. That'll be easier in Rust than Motoko so far due to just existing libraries for JSON parsing. But yeah, like I think that that is a possibility. And in some cases, that may be faster and more suitable for certain types of applications. So yeah. All right, let's talk a little bit about certified web content. And this is just something that I want to talk about because it is something that is a unique attribute of the internet computer and the stack that we've landed on. So the problem and the reason that you need something like this is in traditional web, right? Web 1, you were able to sort of run your own server, maybe out of your home, maybe out of like a local data center or something. It was just kind of like one location. You had direct control over what that server is doing and what it sends. You could probably even interact with that server physically in person a lot of the time. But as we moved over to the cloud, you handed a lot of that responsibility over to other agencies, someone like Amazon, Google, Microsoft, whoever's running your server. It's basically their server that they're allowing you to use some time on. And because of that, what gets delivered from that server on your behalf to your users is determined by whatever the actual owner of the server wants to do with it. Most of the time, these companies are very stable. They're not going to go messing with things. But, if some company wanted to shut you down, they can very easily do that. And not to mention, like, it is possible that like they could take over a server and deliver whatever they wanted on your website. So for running on the blockchain, we can have a trustless model where you don't have to trust this third party to uphold their contract to do what they say. It's enforced by just the guarantees of the structure. So that's kind of how we get here. And then because we have this web content and we want to serve it fast like you would on a Web 2 platform, you don't want to wait for an update round to verify that every single time your content is exactly what it says it is. So because we want queries, which are fast, but only talk to a single node and don't have to go through this consensus where everyone comes to the same terms, the question is, how do we know for sure that this query update is going to be what it says it is? And the answer is basically that we have to pre-compute a certificate of the content that needs to be signed by everyone. And then that certificate we know is trustworthy even when it's delivered as a delivered as a query. So there are other talks that can break this down a bit more. But the basic thing that we have here is a structure where we have labeled trees representing all of your files. And we can take bits of information like request status, time, and the data itself. We can prune the tree by taking things like request status and turning those into hashes so that the data is a little bit less, and we can hash the data itself, and then basically send that through the same chain key system so that we sign the hash they've computed. They go through this process of exchanging their shares. This is the same fundamental tool that we're using to make updates and have that be trustworthy on the internet computer. And then those updates are stored into the same tree, and we can send along those headers along with the assets to the actual canister. So when you request something like index.html, you also get a hash of the bytes that need to come along with that. And then the service worker is able to validate that as they're loading. And that's how we get these performant applications that are still fully trustless end to end. So that's kind of the story of how we get there. Here's some information on how that works if you're curious, because I don't think any more Supernova talks are going to talk about it. But at the end of the day, the question that you may be wondering, if you're just sort of ramping up for building on the internet computer, is if you are controlling something that is like sensitive in your DApp, if you are managing NFTs, if you're managing tokens, you should for sure use ic0.app, and you should avoid using raw.ic0.app. Raw.ic0.app is useful because at the moment it's better at handling things like large assets. So if you're uploading and managing images, video, audio, People are tending to use raw.ic0.app for those purposes because it cuts out the service worker. But if there's any sort of store of value going on, it's best to not trust that any given canister is going to be fully trustworthy. And it's best to go through the ic0.app and make sure that all of your assets, all of your JavaScript, so that managing any tokens and certification that you're getting there, your authentication, making sure that that is not messed with. So that's the takeaway on certified assets. Try and use them unless you're absolutely blocked. And yeah. So is there anything in the Q&A portion before we go on to how authentication works in our applications?
It seems everything was clear. I don't see any question on my side. If you have any question also later, if something comes up, remember to put it in the Q&A and Kai will answer at the end also.
Yeah, all right, cool. All right, so the next portion is, if you have built front ends before, you know that, sure, you can build like a blog or something where you have just information that you're putting out statically into the world. That's well and good, but it's pretty basic. So if you just use the certified asset canister that comes bundled with the DFX SDK tooling, you'll be able to just publish a website to the IC. That's pretty straightforward, right? But a much harder question is, how do I manage users? How do I manage permissioned data that only certain people are supposed to access? In other applications, you may roll your own login system by storing passwords with like hashed passwords in your database. That's usually less preferred because we've all seen how many leaks of passwords and emails go out. Like we all get the "I'm sorry" emails every once in a while. So that's not been the best system historically. People like to trust third parties like Google or Facebook or some other authentication providers with their information so that at least you don't own the risk of logging in. But even then, that has been this huge way of having all of our data exposed and just handed out to anyone. So on the internet computer, we have another option that we've built on blockchain, built on the internet computer, which is our internet identity application. So you've all seen probably this kind of view. This is our own provider for identity management. It's built on the technology of web authentication. So your browser has these cryptographic identities that it's able to generate. And we have come up with a way of associating those identities anonymously with a given, what do we call it? Identity anchor at this point. And that's just like a number, an anonymous user number. That's not actually shared among the different applications, but really it's just a way of proving to any application that wants to integrate with internet identity that the same person or someone who controls a device that is authorized for this identity was able to be in control of that device when they tried to log in. So it's very little information that's passed. Internet identity can't identify your device through any other method besides web authentication. And it's basically just like a anonymous OAuth solution. So how does this work with internet computer applications? By default, when the JavaScript agent is going to interact with any canister, any call to the IC, you need to package an identity into that's going to be used for signing your calls. We start with a default identity whose principal will evaluate to this little string here ending in fay. So if you don't provide a specific identity, this is what's going to make all of your calls. If you don't have any permission to data, that might be fine. You can just use the anonymous identity and your application will work. So if you do something as simple as like the hello world starter or a counter or a number of other things, that'll be totally fine. But if you need each user to start having a different principal that only they are in control of, then you'll want to use a different identity, and you can then identify who is calling the method inside of the canister. So there are ways to do this in Motoko as well as Rust to easily verify who is making a call. So this will look something like this inside of some Motoko code. We can say public and then have this shared message property define the rest of our call. And so we're creating a profile. This is in the IC avatar application that I did a little video series on a bit ago. We can then read from the message here, message.caller, and that is going to be the caller ID of a principal of whoever's made the call. With this little check, you can reject anonymous identity, make sure that someone's actually logged in. And then when you store the information, here I'm using a try data type. You can store using a key of the principal who is the caller and insert into your database or your data storage variable. In Motoko, we could just make that a stable variable. And you can basically create the account such that only a person with that can create. And then on subsequent calls for things like read or update, you can then also use that same principle to determine whether someone has the rights to do those things. Typically, you shouldn't allow anyone aside from the actual owner or the user to make updates or to delete. But if you have other principles that someone might use, like let's say someone also has a plug wallet that they want to link, what you'll then just need to do is have some sort of data structure in your profile or whatever else you're using, where you list other principles that are authorized. So you could just say principal plug identity is this, and then you just need to add a little bit of extra logic to check for plug identity or creator identity or whichever way you want to go. So that's the way that we can gate content. Is caller ID cryptographically validated? Yes, it is. So a principal is just a special format for a public key. And so the public key is secure. With internet identity, you never actually even have the private key or the seed phrase that represents that user. You'll only ever have access to that through a delegation token that you get back from internet identity. And that delegation is time boxed. There's an expiration packaged into it, and even the public and private key of that delegation are only usable to generate an identity until that expires. So it is cryptographically validated. If you send like a bad principal through, the replica of the internet computer will just reject the message. So you can't have an invalid signature, and you can't reproduce someone else's signature because of those properties of cryptography. And then here are some resources that you can link to. We'll share out the slides later. But internet identity is open source. You can go check out the code of how this all works directly there. This is also helpful for if you need to clone it and run it. If you're developing with it on your local environment. We also have a package at DFINITY/auth client on NPM. This makes it really easy to get set up and integrate with internet identity. Here is an auth client demo that I show some code for how to use the auth client. And I've also got a little blog post on it.
Hi, before we go on, there is a couple of questions on the Q&A section, actually. I don't know if you can read those.
Let's see. It's kind of out of my reach.
It's fine. I can read those if you want.
I've got it.
There is one. Oh, you got them?
Yeah. It was like out of my window and I couldn't drag it. So Andrew asks, so even when you're not authenticated with II, your browser has a principal that is the one you showed ending with Fay, and it is the principal making the calls. That is correct, yeah. It is, there is an identity that is associated when you're making anonymous calls, and it will always be that reproducible one, at least in terms of the JavaScript agent. I think that the Rust agent doesn't have that particular anonymous identity, typically because in Rust, we assume that you're going to be operating with that. And this is because the IC needs to sign every message. Essentially, yeah, like this is just part of the spec of the sort of flow of data that we're going to have. Agents represent who they are. That needs to get passed through. It's part of the information that is used in the certification process by the replica. And so that affects like the ability to sign back. And so even if it is anonymous, we want to know who you are. Someone else asks, what if your canister isn't using II? What will this code do? Is II built into all canisters by default? So if you aren't using II, there are other tools for getting a new principal. So there are other applications like Plug, like Stoic Wallet, like I've said, so you can integrate with other tools and they will also be able to give you either a direct identity in the case of Plug or a delegation identity from Stoic or Identity Labs. Additionally, if you're doing something, and I don't recommend this for a client-side application, but if you're doing something like you're working in like a Node.js environment and you want to like repeatedly make calls, or if you do this during tests, under the @DFINITY/identity package, we expose some basic cryptographic identities for a ED25519 key identity or a SecP256K1 key identity, where you can use those cryptographic standards to generate an identity from a public-private key pair and reproducibly get your same identity from that information. We also have a way where we can take a seed phrase and turn that into an ED2551. Wait. No, I think that one is a SecP256K1 key identity from the seed phrase. And you can use that interchangeably with DFX versus your application. But like I said, I don't recommend using or instantiating that from a secret in the browser just because of the nature of browser security. It's really best to rely on a provider a lot of the time. And so II is one good solution, but I'm sure that you could also find other creative ways of relying on an auth token, for example, from login with Google. There's probably a way that you could turn that into an identity. You could also use MetaMask. We've seen some people do that fairly straightforwardly. So yeah, pretty much any way that you can get yourself to a consistent secret that you can turn into a 32 byte hash that you can then create an identity from, it will work at the end of the day. All right, we ready to look at some code? All right, so this is a example project using the DFINITY auth client. As you can see here, I wrote this in TypeScript, but I've even got a branch for just vanilla JavaScript. Setting up is going to be pretty normal for any front-end application. I guess I forgot to say npm install. Anyway, you clone the application, you start DFX running locally, you can deploy your canisters. So that starts with dfx.json. Here we have a who am I canister that's going to simply use that message dot caller, and it's going to return that, returning a principal. So whoever it calls is going to get back a response. And then from there, we also have, this is how you set up a front end. This is how you set up a front end project in DFX. If you use the DFX new command to give yourself a starter project, you'll get one of these by default. But here we label that this depends on who am I, because it's going to make calls to it. And so this will try and build the who am I canister before the front end gets built. We point to the front end. This is just going to be referenced in the Webpack config. And we have a source where we're going to load up any assets from this assets directory, make those available statically in the final build, and anything in dist, so the output from npm run build. So we just take all of that. After we upload the certified asset canister, then all of this extra information, all of these files are going to get uploaded and synced to your canister. And the type assets tells us that you're going to use the certified asset canister that comes built with DFX. All of this is possible in your own project. So you can take a look at something like Internet Identity or the Cycles wallet on the DFINITY GitHub page. Those are places where the canisters have implemented custom asset serving. There's actually a Rust crate for adding this certified asset functionality, and you can just drop that into your project, and any canister can serve its own assets, basically. But this one is just one that we give you by default to keep things simple during the onboarding. And then just some other bits of information that aren't as important right now. So let's take a look at what this looks like in practice then. HTML is the entry point. You can link to things that are in your assets folder just directly like you would on a normal static server, like if you're dropping this into Netlify or yeah, pretty much anything. So just relative pathing, anything that's in there. You can link to images the same way. Then our index.ts, this is where we're going to have the logic that we're actually going to interact. So this is all managed because of Webpack, of course. That's going to bundle our code. So that's how we're able to do these imports with this syntax. But we just set up our application here. We initialize the auth client, after which we can do a check to see if you are authenticated. So if you, by default, if you initialize the auth client, it's going to give you the anonymous identity. And if it hasn't found anything stored in your local storage, that's where you're going to be at. So we just do that check. If you are authenticated, we can take you off to the next view. Otherwise, we need to give you a way to log in. So render a little login button. And then here is how we do a login with the auth client. So you have an on success callback, pretty straightforward. Then with the identity provider, here we're making this be based off of your development environment variables. So if you've done DFX deploy network IC, this DFX network variable gets set, and that will be set to IC. Then we know that we talk to the live internet identity. Otherwise, we'll look for a local II canister variable and use that URL instead. So that's the kind of complicated environment logic here. Let's see, someone asks, Mikhail, does this web have all state managed on the client by TS code, not server-side rendering? Yes, this is all client-side. You can't execute JavaScript server-side rendering yet. Check out the Azel project by LastOwn.js if you want to see something that may have the ability to do server-side rendering on the IC. But for now, we assume that you're just kind of shipping static assets that either need to do stateside rendering, or you could use a static site builder tool to pre-generate all of the pre-rendered files using something like Gatsby.js, SvelteKit, equivalent ones for Vue, or some of your others. So the Jamstack pattern works pretty well for the certified asset canister. And here we specify max time to live. This is customizable. By default, on the current version of auth client, it'll last for, I think, 1 day. That's going to be taken down as a default setting to, I think, 8 hours pretty soon on the next release. But you're also going to have always the ability to expand that up to 8 days. And I think II might start accepting up to 30-day expirations at the request of things like OpenChat. Yeah, and then the rest is just some like JavaScript considerations. Not all that interesting. But we can take a look at what this looks like in practice. So here we come in. We're going to, let me actually do this in a guest window really quick. Just make sure I don't leak anything. All right, so I click the login button. It is going to take me to identity.ic0.app. I provide my identity, and I can tap my security key and proceed. This will take me back to the application. It's passing this delegation identity through the window.postMessage method. And now, if I click this application, we're going to talk to that who am I canister using the JavaScript agent with the identity that we've just been given back from Internet Identity. It makes the call. And here we go. That's the identity that I use. Yeah, and you can see that if I log out, I've wiped all of that memory. We try and do it again. Now I can come back here, re-authenticate. And when I make the call again, even though I wiped it, I've got a fresh delegation. I'm going to be able to reproduce that principle over and over again. Yeah. Andrew asks, do you need a local II canister to test local authentication? Could you authenticate locally with your real II? Yeah, so at the current time, you do need to have a local II canister to test local authentication. Currently, the local replica does not accept signatures from the mainnet. From what I understand, this is something that the replica could work on, and it could be set up to handle this, but that hasn't been done yet. So that's kind of the current state of things. We're also looking into seeing if DFX can provide like a mock II pre-built, so you can just enable that for your project and have a little less overhead for the tooling. But yeah, for now, the current process is basically to follow these guidelines that I have here, where just clone the Internet Identity project in parallel. I always recommend removing the cache for this because right now DFX doesn't sync the canister IDs between multiple projects. So if you start with a clean DFX, if you start with a clean DFX and you follow these patterns, you should get a really consistent deployment. And even your canister ID should end up matching this for your local II canister repeatedly if you're starting fresh each time. Otherwise, you may need to like replace this if you're cloning this project and trying it yourself. All right, so this is everything that I wanted to cover. So we've got 10 minutes remaining. Happy to talk about pretty much whatever you want. Whatever is going to be helpful for getting started for the Supernova Hackathon.
Yeah, if you have any question, please shoot it in the chat or on the Q&A tab, and we can talk about it. Maybe, I don't know, for someone who's like doing their first steps in this direction, and do you have any suggestion? Do you have any advice on what they can do to get started the right way? Some quite common mistakes that can happen while toggling this type of things. I don't know, a word of wisdom, I would call it.
Yeah. So my tips for someone getting started would be, if at all possible, use the Cycles faucet to get your Cycles wallet. That's the easiest path that we have right now. And one of the bigger pain points of getting onboarded is like getting your Cycles wallet going. And if not doing that, or if that's not going to work for you, maybe you don't have a GitHub account that's mature enough, or a few other things that could have gone wrong. Maybe you've done it before. Then I recommend really just closely following the network deployment guides in the smart contracts quick start. Just like, I know that it's nice to breeze over things, but it's a big cognitive load if anything goes wrong in the process. So just really precisely following it will hopefully save you a lot of pain. Because as soon as the wallet is set up with DFX, things will go a lot better. All of your deployments will be able to go through the wallet, which is required for Basically, you can't hold cycles without a wallet or a canister holding cycles. So the wallet is there to hold your cycles and then talk to the management canister, which creates new canisters for you. After the canister is created, the cycles wallet's going to make DFX your principal there. It's going to make that be a controller for the new canister. And so then you can upload, you can make calls, all of that through DFX. But specifically for like the installation and canister deleting, it's just really you're best off if you've got like a properly configured wallet.
Thank you. There is a question from Psycat in the chat. He was thinking of building a multi-sig wallet for something that's not yet thought through. Do you think there are any limitations on the platform currently that might prohibit this?
No, I don't think there's anything that would be preventing multi-sig. Like the same fundamental cryptographic signatures, as long as you are ultimately producing a signature scheme that is valid on the internet identity or the internet computer replica, you'll be able to produce that signature and send a message with it. So whatever means you take to get there are totally fine. And multi-sig is functionally what we're doing for talking to the Bitcoin ledger as well as Ethereum, just through an internet computer native strategy there. Yeah, so in a working authentication workflow on my GitHub. So yeah, that code that I was sharing here is available at auth client demo. Frederick provided 4 environment variables for installing the dev version. Yeah, I think I use a couple of them in my demo now. I've started to, that's one of the things is that their team, I think that there's an example in the internet identity repo that you can follow as well. They're kind of moving on their own pace. I'm not directly on the internet identity team now. But the auth client demo is still pretty simple, and it does work with the latest installation instructions, even if they've got an even more optimized version. Another question is Wallet an open source app? Yes, that is github.com/DFINITY/cycles wallet. I'll drop that in the chat as well. And any guidance to budget the amount of ICP or cycles required to get an initial basic app up and running? Yeah, so if you've just got like a basic thing where you're trying to test out the deployment workflow, the default settings are to spend, creating a canister, there's a fixed cost of 1 trillion cycles. So like, that's like $1.20 or something. And so that's the fee. That's going to be at the baseline. So if you're creating a canister and you're deploying the hello world, that's going to be like $3 coming up on $4 already. I recommend specifying, if this isn't going to be something that you want to run for a long time, you're just kind of testing it out, I'd drop down the amount of cycles that you start with to like 1 trillion. So you can do DFX deploy -- with cycles in the DFX command. And you can specify the 1 trillion as opposed to the default, which is 3. For stuff that I've deployed with 3 trillion cycles, I've deployed like the JavaScript agent docs and a bunch of other sites. and canisters with the 3 trillion that are running easily a year later, not about to run out. So if you have like a low traffic or just like a static website where stuff is mainly handling queries, and it doesn't have to like do a bunch of compute cycles, 1 trillion is going to last you quite a while. And yeah, you can hold on to your cycles otherwise.
Okay, I don't see any other question, and it's good on one side because we are at the end of our time. So thank you so much, Kyle, for this. It was really nice, and the presentation was super explained extremely well. I've seen people getting really interested in it. So thank you so much for this. Just remember everyone to get onto the Supernova website, getting onto all the links that Matthias and I've been sharing in the chat, and also Kyle has been sharing in the chat. And if you need anything like explain a little bit deeper, keep following the webinars, but also go on the YouTube channel of DFINITY and check out also Kyle, Coding with Kyle, right?
Mm-hmm.
In which Kyle explained a lot of other things, I suppose. We're not gonna go in details right now, but you can go and check it out. I got information that the video of the first webinar is gonna drop on Thursday on the DFINITY channel. So I think we're gonna wait for next Thursday for this video to drop on the DFINITY channel. Okay, thank you
And
so
I'll
much
say,
to everyone.
if you need ongoing help, also check out the DFINITY forum at forum.dfinity.org and get in the community developer Discord. I am frequently in those spaces to answer questions and just support the developer community. And so those are really great resources as well.
Yeah, Kyle is everywhere, all the time. Okay, thank you so much, everyone, and see you next time. Have a nice one. Bye.